Okay, so let's talk about higher dimensional Taylor polynomials. You already know one, right? What's the one you already know? Or what's the part you already know? Okay, perfect. So from Calc 1, right? F of x is approximately f at some point a, right? That's like the dumbest approximation you could do. That's just, the function is about how high it is where you're interested in. Then what's the next thing you could do to adjust?
Plus f prime a.
That's f prime at a. Okay, times the change in x, right? I'm just gonna, but that's an x minus a, right?
Yeah.
And then what's the next one?
The
Second
second derivative.
derivative
Of a.
at a. Good.
X
Or
delta
over
x
3 factorial.
Delta x squared over 2
2
factorial.
I can do that on that test.
Yeah, so remember this one's over 0 factorial, which is 1. This one's over 1 factorial, which is also 1. The first time that thing comes into play is here. What's the,
just 2.
yeah, which is just 2, right? And then the next one you would have is
Third derivative
f triple prime at a,
Delta x cubed
change in x cubed,
over 3 factorial.
all over 3 factorial.
No, only the f triple prime of a, I believe, was over. No,
It doesn't matter.
Doesn't matter.
It's multiplication, right?
Oh yeah, okay.
Okay, so, and then plus etc., right? Okay, so I said this got bad in multidimensional calculus. And the reason I said it gets bad is not that it gets harder or different even, it's just that it gets to be cumbersome quick. So the reason it gets to be cumbersome quick is if I'm looking at f of x and y, right? Okay, what's your dumb guess for,
AB.
should be at f of a, b, right? Perfect, right? That's like your dumbest possible guess is that it's always the same height.
Plus the partial with respect to x at a
At a,
b
b, right?
times delta x
Times the change in x.
plus
Okay,
When
so
you multiply
partial.
them, the f of y, that's plus f of ab times delta y.
yeah, so this is the linearization, right? This piece here.
So that's the equivalent of the first 2 terms of our original Taylor polynomial.
Ah, yeah, right? Which we could think of as first derivative bits and constant bits, right? Constant bit, first derivative bit. Okay, then,
Oh,
And the
sorry.
second
New line.
yeah,
Do x, a,
So
and
x,
x,
and x,
y, and y,
yeah,
y, x. You have to
okay.
do all of them? Or?
Yeah, and this is the, right? Because I had to do both of them here.
So f x x a b
So I need fxx at ab
times delta x
times the change in x
squared.
squared over 2, right?
Yeah. And then
Plus
f
fxy
y
fxy
at ab.
at ab
times delta x delta y.
Yeah.
delta x delta y
Over 2 factorial.
over
Over 2.
2 again.
Why would that one be xy?
Because you have
First one's x, second one's y.
Yeah, so you're saying, okay, I'm going to go in the x direction first, then the y direction, right? And so I have to go, okay, I went a little bit in the x, and then I got to go a little bit in the y. Just like here, I went a little bit in the x, and then I went a little bit in the x again, right? Okay, what's your next guy going to be?
fyx
fyx at ab
times delta y and then delta x.
delta y delta x, right?
Oh,
all
we have
over
to do
2.
every
And
second order partial.
yeah, and that's really the thing, right? It's not harder.
You just
It's
have to do
just-
both for every previous one.
Yeah, it's way, way more time consuming, right? Because here I was just getting one more term, right? Here I'm going to get one term, then 2, then 4,
Then
then
8,
8, then 16, right?
It'd be like fx.
Nope.
Fx.
I trust that you guys could build the next ones, right?
Yeah.
At this point here, I'm missing one term. So what's my one term? So I've got fyy at ab
X, X, Y, X, Y, X.
delta y squared
Over
all over 2. And then really, I'd need plus dot dot dot, right?
Yeah.
And the next one would be 8 terms. So I'd need f.
X, X.
And it's all of them plus the previous.
Uh-huh, yeah.
Y, Y.
But most of the time you won't need to go past a few terms because it's
Y, Y, X.
just getting closer and closer to the absolute or the
Yeah.
value.
Okay. So, Kaz brings up a good point, which is you maybe don't need to go tons further, right? Because
fx and xy is
yeah, so one thing, good. I can get rid of not these 2 terms, but I can combine these 2 terms, right? Assuming this thing actually admits a Taylor polynomial, right? That means it's differentiable, and the derivatives are also differentiable, right? Okay, see that? So if they're also differentiable, they're also continuous, and I can collapse these 2 pieces. So instead of getting 4 new pieces, I only get 3. In the next stage, I would not get quite 8, but I can combine a couple of them, right?
So like 6.
Yeah, so it's not great cost savings, but at least it's something, right?
It would be like 16 minus 4.
Yeah, you guys see this? Like, there's a little bit of collapsing you'll be able to do at each stage, but it's still not enough to make this a really, like, I want to go do this. Do I want to send a computer down this path? Yeah, sure.
Yeah.
Like, who cares?
Go
A
for it.
computer will happily calculate 400 of these, and then it'll make the Taylor polynomial for you, right? So don't do this by hand, but by computer. Yeah.
As it explodes later.
Yeah, I mean, you're not going to fall into an infinite loop, though, right? This is an operation that'll complete.
Yeah,
See
you
that?
just have to set an endpoint.
Yeah, I just have to
However
cap
many
it
to do.
somewhere, and that'll be fine, right? Cool? Questions on higher order Taylor? Just kind of do it the same way, right? Cool. So, yeah, maybe I should write this. These 2 terms, right, could collapse into what?
One of just f x y.
Yeah.
Two terms.
Yeah, pick one, right? At AB times delta x, delta y.
Yeah, but you have 2.
Well, there would be 2 of them divided by 2.
Yeah.
Yeah, right, there's 2, and they're each divided by 2, so I just can drop the 2, basically. Cool? Your book phrases it that way. They don't even bother writing both pieces down.
Now, why would we not just do fxx and fyy? Why do we need to include the?
Yeah, why do we need these?
Like
bits,
every
right?
possible.
Yeah,
mixture?
okay, so,
Well, aren't there more directions we can travel in?
Yeah.
Point with quiz.
yeah, I need to compensate for, okay, if I'm going this way, right? Like, the dumbest thing I could do is stick a tangent plane on here.
Uh-huh.
But I'm not talking about a tangent plane anymore, because these guys. Right, so if I'm going to add some of this twist information,
Okay.
right, I can't just make it curved in the x direction, curved in the y direction, and not bother with the idea of, well, you got to go out a little bit in the x and a little bit in the y, right?
Okay.
So I need that twist information. Cool? Also, at the end here, we should mention, what is this, like, if I truncate here, what category of thing is this Taylor approximation?
Partial series.
It's a degree 2.
Still a surface, but it's not a plane.
Yeah, it's still a surface, it's not a plane. In some cases, at least, right?
Oh, would that
It'll
be
be a
paraboloid?
paraboloid. You guys see that?
Can we
Next.
just call it like the second degree approximation?
Yeah. I just want you to notice that it's probably a paraboloid. You guys see that? To find out which paraboloid, right, you're going to have to complete the square on it a little bit, and it's going to be kind of annoying. But it will be a paraboloid.